Dear students, Assalamu alaikum and welcome to another program on Software Engineering 1 course. From the last two programs, we have been discussing requirements elicitation and analysis. In this regard, we discussed two very useful methods for requirement elicitation and analysis. However, there is another important activity that is carried out during the requirement elicitation and analysis process. That activity is generally known as system modeling. In today's program, we will explain the role of system models in the requirements analysis process. We'll describe different types of system models that are produced by the analyst. And finally, we'll introduce data modeling concepts and entity relationship diagrams. During the analysis, we produce various kinds of models. But before we discuss the system models that are produced during the analysis phase, let's start by defining what is a model itself and what do we mean by modeling activity. A system model is defined as a system model is an abstract representation of systems whose requirements are being analyzed. Developing system model is very useful activity in the requirement analysis phase. They help the analyst to understand the functionality of the system, and the model are used to communicate with the customers. Also, they are the first technical representation of the system. Dear students, analysis modeling may begin when we have a statement of scope of the project and we get understanding of the system and we have a good idea of user requirements. The models that are developed by the analyst are generally dependent on the techniques and the analysis methodology we use. However, in traditional requirement analysis, the analyst produces a number of different models. The most common models that are produced are shown in this diagram. In the center, we have the data dictionary. The system analyst produces an entity relationship diagram, or he does the data modeling. He also does the process modeling with the help of data flow diagrams and the behavior modeling, which is done with the help of state transition diagram. Also note that when we do the data modeling, the analyst also writes down the data object description. Similarly, with the data flow diagrams, we have to write down the process specification or the P specs. And in the behavior modeling, we not only prepare the state transition diagrams, but we also write the control specification. Now, as you have seen in this diagram, there are different types of models which are produced. We mentioned three of them, and they are generally called the data modeling, the process modeling, and the behavior modeling of the system. Now the question is, why do we prepare so many different models and not just one which can represent the whole system? The simple answer to this question is the complexity and size of the systems that we analyze and develop. The idea behind preparing various models is that each model focuses on a part of the system, making it possible to analyze various aspects of the system independently. This approach is not unique in software engineering. The same philosophy is used in other engineering disciplines. For example, an architect produces a number of different drawings and models of a building. Each drawing focuses on a particular aspect of the building. For example, he prepares one drawing showing how the building will look from the outside, how the elevation will look like. Another shows the layout of the rooms and positions of the windows, doors, etc. He might be producing many other similar drawings, where each drawing depicts a particular aspect of the building. But if you look from the civil engineering point of view, he also prepares some models. Of course, his models might be in the form of numbers, how many beams will be there, what will be the position, strength, etc. He might be doing the finite element analysis of the building. So, we have produced various different models for the same building. The question is, why do we prepare so many models? Of course, each model which is prepared by the architect or by the civil engineer gives you one particular view of the building. Also, not a single model gives all the details. One has to look at all the models to get a complete understanding or a complete picture of the building. In a similar way, software is a very complex entity, and software engineering is a complex undertaking. When we are looking at a system as a whole, which is very complex in nature and huge in size, we should not be modeling it as just one single entity. It's difficult to understand it as a whole. Therefore, we prepare various models, where each model shows us the details of one particular aspect of the system, making it easy for us to understand the system in parts, and then we can build the whole picture out of the pieces. Now let's define what is data modeling. Examines data objects independently of processing. In data modeling, we create a model at the customer level of abstraction. And a data model indicates how data objects relate to one another. Data modeling is one of the models that is prepared by the system analyst or the software engineer while he is analyzing a system. Data modeling really only focuses on the data that the system will operate on, or the data that will be stored and consumed by the system. Dear students, while we are doing the data modeling, there are some basic things the analyst looks for. He has to discover what are the data objects, what are the attributes, what are the relationships, how different data objects are related to each other, and the degree of the relationship, and the cardinality of the relationships. These are different things one has to look at when he is doing the data modeling. Otherwise, the data modeling cannot be done completely. So let's look at these parts independently in little more detail. What is a data object? A data object is a representation of almost any composite information that must be understood by the software. It can be an external entity, somebody who is producing or consuming the data produced by your software. It can be a thing, a person. It can be a role, for example, a salesman, a role played by a person. An entity can be an organizational unit, for example, the accounting department. A data object or an entity can be a place, for example, a warehouse, a shop, or a building. Or it can be a structure like a file. A data object encapsulates data only, and there is no reference within data objects to operations that act upon the data. And that is the basic philosophy of preparing so many models. While we are looking at the data that will be used and produced by the system, we do not look at how that data will be processed by the software. Then each object has the instances. For example, a particular book is one of the instances of our data object. Then each instance can be identified uniquely by a key. And it plays a very important role in the system. That is, the system cannot function without accessing the instances of the objects on which the system operates. Dear students, every object has a set of attributes that act as an aspect, the quality, the characteristic, or descriptor of the object. The attribute basically define the characteristics of an object. An attribute can be a simple attribute. That means for each instance, it has a single value. For example, the age. If we are talking about the age of a person, then one particular person can have a single value for the attribute age. The attribute can be composite. That means one attribute has parts. One example of a composite attribute is the name. We can decompose the name into 2 or 3 parts, the first name and the last name and the middle name. These 3 attributes make one composite attribute. The attribute can be a derived attribute. A derived attribute generally is not stored in the system. Rather, its value can be derived from whatever information is already stored. For example, if we have stored the date of birth of a person as an attribute, then the age can be derived from the given date of birth. An attribute can also be a multi-valued attribute. That means for a single entity, for a single instance, an attribute can have more than one values. So just the opposite of the simple attribute. For example, the telephone number attribute may have more than one values for the same entity if that entity has more than one telephone numbers. So as an analyst, we not only look at the attributes, but we also look at their composition and their properties. Then one or more of these attributes must be defined as an identifier of the object. And that identifying attribute or the set of attributes are generally known as a key. For example, if you are talking about a student, then the registration number of a particular student uniquely identifies that student. So we take the registration number as the key of that object. The set of attributes that is appropriate for a given data object is determined through an understanding of the problem context. For example, if you are talking about a car as a data object, then a car can be identified uniquely by more than one of its attributes. For example, the car registration number, the engine number, the chassis number. The question is, which one should be selected as a key? Of course, the choice depends on the way the information will be later retrieved. We have to look at that the information about that object is retrieved most of the time by using which attribute. And we select that one as our key. So the number of entities which participate in a relationship is generally known as the degree of the relationship. For example, if we have 2 entities or 2 data objects, the student and a course, then we say a student can take a course. So there is a relationship between the course entity and the student entity. This relationship has been created between 2 entities. That type of relationship generally called the binary relationship. A relation can be between the same entity. Generally, it is called the unary relationship. We can have the relationship between three entities of our system, and that type of relationship is called ternary relationship, and so on. While we are doing the data modeling, we also have to look at the cardinality of the relationships. Cardinality is the specification of the number of occurrences of one object that can be related to the number of occurrences of another object. Now, two objects can be related in one-to-one relationship. That means one instance of one entity can be related to exactly one instance of the second entity. The relationship can be one-to-many. In one-to-many relationship, one occurrence of an object can relate to one or many occurrences of another object. For example, if we say that we have the entity student and the entity course, then we have to see what is the cardinality of the relationship. Of course, these two entities have the relationship that a student can take a course. The question is, one student can take only one course, or he can take more than one courses. If he can take more than one courses, then each instance of the student entity can be related to more than one instances of the course entity. The relationship can also be many-to-many. That an occurrence of an object A can relate to one or more occurrences of another object B. And while an occurrence of B can relate to one or more occurrences of A. These things will become much more clear when we really look at the data modeling activity through an example. Dear students, traditionally a graphical notation called ER diagrams is used to do the data modeling. ER diagrams enable a software engineer to identify data objects and their relationship using a graphical notation. The graphical notation used in ER model is the real strength of this model. It uses very simple graphical notation to depict various parts of your data. In ER data modeling, we focus solely on data, and thus representing a data network that exists for a given system. Of course, this is the continuation of our basic point, that each model focuses on a single part of the system. And ER model is specifically used for the data modeling. In ER data modeling, as we said before, a number of notations are used to represent entities, relationship, and rest of the information. Unfortunately, there are no standards notation. Different people use different notations to represent entities and relationship and the rest of the things. That's not very significant, though it's very confusing. However, we will be using these notations in our ER modeling. Unfortunately, there are no standard notations for ER model. Different people use different symbols to represent entities, relationship, and the other information. We will be introducing the symbols while we are going through an example. Our example is a very simple example which only focuses on the part of the data in a typical university environment. The data modeling basically starts by looking at the entities. Of course, in the university environment, you might find hundreds of different entities. But as an analyst, you have to focus on only those entities which are really required in the system, and rest of the entities must be ignored. So the first step is that you should identify the entities. The entities we have identified are the department, and now you can see that we are showing the entity or the entity types using a rectangle. And inside the rectangle, we write the name of the entity or the data object. Another entity we have identified is the faculty, the teachers teaching in that university. The students, different programs which are offered by the department, and in each program there are different courses. So these are some of the major data objects and entities which make the part of our university database system. Once we have identified the major entities, of course you can put lot more entities there if you are really interested to have the information about the other objects. After identifying the entities, now we have to identify the attributes of each entity. Attribute basically is the information you are really interested in storing or processing. The attributes we have identified are: the department has the attributes, the department code and the department name or the D name. And see how we show the attributes of an entity. The name of the entity, for which we use a rectangle. For the attributes, we use an oval symbol. And this is connected with a straight line with the entity. Similarly, faculty has the attributes ID. It has another composite attribute name, which is composed of the first name and the last name. Note one more thing here, that in each entity we have underlined one of the attribute. The underlined attribute basically shows the key attribute of that entity. Similarly, we have another entity, student. Registration number has been taken as its key attribute. Every student has name and address and the telephone, and you see this is a multi-valued attribute which has been shown by double oval symbol. And similarly, the attributes of other entities have been shown on this diagram. Once we have identified the attributes, now we have to look at how these entities are related to each other. That means we have to identify the relationship between different entities. Some of the relationship in our example are shown in this diagram. Department is related with faculty. We use a diamond symbol to show that these two entities are related to each other. Inside this symbol, we write the name of the relationship. Of course, you can use any name, but it's better to use a name which is meaningful. Now, if we read that information, it says department has faculty. That means the teaching staff. Similarly, a department offers programs, and a program contains courses. Program is also related with student. That means student registers in a particular program, and student also enrolls in a course. So we have identified the relationship between different entities, but still a lot of information has to be displayed on the ER diagram, and that is the first is the cardinality. Now cardinality is shown by writing the number close to the relationship name. Now how to read this one? Now it shows that one department is chaired by only one faculty member. Now you can read from the both side. If you read from that side of the entity, it says one faculty member chairs a department, or one department is chaired by one faculty member. The second type of relationship which is shown here is 1 to n. It says one department has many faculty members. N means one or more than one. And now see one more thing here, another notation where we have used a double line there. What the double line shows, it says that each faculty member must be working in a department, or each department must have some faculty members. So we cannot have a department without a faculty member, or we cannot have a person working there as a faculty member and is not working in any department. That's what is called the total participation. But if you compare with a single line, it says that there might be a faculty member who is not a chair, which is quite possible. That only one faculty member can be the chair of a department, and rest of the people can still exist, but they are not related to department as the chair of that department. There is another relationship between programs and student, and the relationship is n to m. Now how to read that type of relationship? It says in one program more than one students can register, and one student can register in more than one programs, giving us n to m relationship. Another interesting thing to note here is the relationship can itself has the attributes. For example, the relationship register has the attribute registration date, the date on which a particular student registers in a particular program. Similarly, a program contains many courses. As you are taking BS Computer Science, that's the program. So it's one program and it has many courses. But one course is related to only one program. But if a course, the same course with the same code, with the same credit and rest of the information can be offered in more than one programs, then this relationship will become n to m relationship. And the last thing here is that the course and the students are again related with each other with the cardinality of m to n, which shows that one student can enroll in more than one courses, and in a single course more than one students can register. We have very briefly looked at how to make ER diagrams. In today's program, we explained the role of system models in the requirements analysis process. We emphasize the point that preparing different system models are very important activity to get an insight into the system which we are analyzing. We also described different types of system models. We introduced to you the data modeling concepts and how the ER diagrams can be used to model the data of the system we are analyzing. Till the next program, Allah Hafiz.